Now, I know that generative AI is the new hotness, and this is the thing everybody's talking about. However, generative AI and even generative bio, that's not the end, that is the beginning. Sometime in the next decade, artificial intelligence will be working alongside something called organoid intelligence. And I know that doesn't sound real or urgent, but here's what it is. Organoid intelligence uses biological materials, so typically this is brain cells pulled from mammals, including humans, to leverage inherent capabilities beyond what we can do in silicon. I know that sounds nuts. However, this research is already underway in Baltimore at Johns Hopkins University. And what you are seeing here is a brain organoid. So this is a tiny living structure made up of real cells. It's a tiny little replica. You start with something called an induced pluripotent stem cell, which you can get from anywhere, and sort of nudge it biologically and chemically to induce it to become a different type of cell. So long story short, we now have cells like this, which are being used to create new types of computers, which means that what's on the horizon are biocomputers made out of human brain cells.
Hey guys, this is Tim, and I'm speaking to you through some free text-to-speech website that I found online. And hey, I know it's kinda weird, but I'm doing it this way for 2 reasons. For one, I am sick today. My throat hurts and my voice sounds weird, so there's that. I also thought it would just be kinda funny, and you know I love to laugh, ha 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 ha. But also because an artificial robot voice seems sorta fitting alongside the insane things that you are about to hear. I have been seeing this topic of so-called biocomputing appearing in headlines all over the place in recent months, and I've been planning to make a video about it, but life has been hectic and I have been busy trying to finish the current project I'm working on. But as my subscribers know, transhumanism is a topic that I'm pretty passionate about, and I feel compelled to cover this because here in the era of artificial intelligence, new transhuman technologies and dystopian biotech advancements seem to be rolling out every day, and it's all developing so fast that we can hardly keep up with it. And I don't think people realize how close we are getting to the actual reset part of the Great Reset. There are so many world-altering technologies being developed right around the corner, just waiting to be rolled out into a world that will never be the same afterwards. And today, I was listening to some lectures and presentations from the pretentiously named United Nations Global Compact Leaders Summit 2024, which just concluded last week. And I cut out a few clips that I think you may find rather interesting, so check this out.
Right now, everybody is talking a lot about artificial intelligence, and in particular, generative AI. But what we have started to see, because AI is clearly, it meets the criteria for a general purpose technology, is that AI is actually not the only one. It's the thing everybody's talking about. It's the social media app or the HTML of today. But it's not the only emerging technology that will ultimately radically reshape society and our economies. So artificial intelligence meets the criteria, but there are actually 2 others that are about to create a liminal period between profound disruption and hypergrowth. Those are biotechnology and advanced sensors. So each one of these areas of innovation has the ability to radically reshape the economy and society for decades because they build on each other. They are each of their own accord platforms, but together they form sort of this new cycle of activity. They actually intersect and converge in different ways that produces new platforms, a flywheel of disruption. You could call it a superstorm of activity that's about to emerge, or rather, a super cycle, which is what we're calling it. So artificial intelligence, advanced sensors, and biotechnology, they are converging into a powerful new force that we are calling living intelligence. So living intelligence is composed of these overlapping strands of technology, and each flashing these bright red signals that are difficult to ignore, pointing to a fundamental economic and societal shift. What we need is actually more types of data. You're hearing a lot about large language models, or LLMs. Those are not enough. So for all of us, your companies, society, for everybody to really make use, more meaningful use of the data that we create and that surrounds us, we don't just need to predict what people will say next, that's an LLM. We need to be able to predict what people will do next, how they will behave next, what choices they will make next. So that's a large action model, and that is already in the process of being born. Let me flip over to one more example because I think it's very relevant for the rest of the talks that you're going to listen to today. Here's where artificial intelligence overlaps with biology, which most people don't think typically go together. So a few months ago, a brand new AI model called Evo launched. It uses biology, the language of biology, so that's DNA, RNA, and proteins, to make predictions and enable design. So if you're using ChatGPT to help write your emails, you're going to use a system like this to help you come up with new types of materials. Which means that soon after generative AI is generative biology. And that may feel like it doesn't impact every single person in this room, but bear with me because it does. So one of the divisions at Google, DeepMind, built an AI tool. They've built a ton of AI tools, but one of the tools is this thing called Know. Here's what's very interesting about this tool. It created 2.2 million new materials, which is unheard of. There's no way that human scientists could have done this on their own. But through simulations and again, combining AI and bio, 380,000 of them are stable enough that they could power future technologies. So long story short, we now have cells like this, which are being used to create new types of computers. Which means that what's on the horizon are biocomputers made out of human brain cells, which has enormous implications for business, but also for ethics. This could dramatically help the global south. It could also leave developing economies in the global south further behind. So, given what you've just heard, I want you to think about this for just a moment. Right now, today, this is the worst that our technology will ever be. So I hope you can see that we have entered a period of rapid transformation. Generative AI, yes, talk about it a lot, but it's not the only thing. We've got two other general purpose technologies that make up the super cycle, which means that while everybody self-identifies as Gen Z or Gen Alpha or Boomers or Gen X or whatever, it doesn't matter because collectively we are all going through something momentous. We are the transition generation. We are Gen T, all of us. Everybody alive today is going through a great transition, and our society is going to look radically different in the days after. And if we don't do effective planning, we're gonna find ourselves 10 years from now having even more challenging conversations than we are today. So this is the end. We need a public-private partnership, a strong one, to help everybody get through this transition. So let me end on two recommendations. The first is that governments should work with the business community to establish some form of a Department of Transition, to create a soft landing for Gen T in the future. That department, and it can be part of what we are doing as the Global Compact, but this kind of needs to start right now. We need models that are informed by data. Which technologies will the tech supercycle impact? Which countries will they impact? How will GDP be impacted? And what do we need to do now to adjust the workforce?
Hi there, viewers. This is Tim again, and I'm still using a robot voice. This time I'm using a little girl's voice. Isn't that weird and funny? Ha 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 ha. Well, now that you saw those clips, I just wanted to end this video off with this recent article on the topic of human brain cell computers that run on dopamine. And I know what you're thinking, that sounds like a Babylon Bee parody headline, but it's actually a real news headline and a topic that has been getting a lot of traction in the scientific and tech communities. I'm gonna use a different robot voice though, because even though my voice is sorta cute and funny, ha 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 ha, I want to address this article seriously.
The soul of NVIDIA, the intersection of computer graphics, physics, artificial intelligence. It all came to bear at this moment. Well, I think we have some special guests. Do we? Hey guys. So I understand you guys are powered by Jetson. They're powered by Jetsons. Little Jetson robotics computers inside. They learn to walk in Isaac Sim. Ladies and gentlemen, this is orange, and this is the famous green. They are the BDX robots of Disney. Amazing Disney research. A new industrial revolution. Every data center should be accelerated. $1 trillion worth of installed data centers will become modernized over the next several years. Second, because of the computational capability we brought to bear, a new way of doing software has emerged, generative AI, which is going to create new infrastructure dedicated to doing one thing and one thing only. Not for multi-user data centers, but AI generators. These AI generation will create incredibly valuable software. A new industrial revolution.
Earlier last month, we wrote about how mainstream AI workloads are too resource hungry and how it costs millions of dollars a day to run large language models like ChatGPT, which is quite unsustainable. This has led to a number of endeavors to create more efficient computing platforms like neuromorphic computers which, unlike conventional computers, are actual hardware versions of neural networks and are much more energy efficient. They are, however, still made of the same materials as conventional computers like silicon, aluminum, gold, and copper. In yet another endeavor to make a more efficient platform, a team of Swiss scientists have ditched conventional materials altogether and have decided to literally put the neuro in neuromorphic, with actual human brain cells. Biocomputing with human brain cells. That's right. This post is about a living computer made up of 16 organoids that possess the same biological tissues and cells as actual human brains. Now in our last post we talked about how clumps of biological cells, called organoids, can exist and function independently from the organism that they come from. For example, we talked about how scientists use clumps of human lung tissue to study human lung functions. These clumps of cells have a life of their own and are even being studied for their healing properties. Similarly, this team of Swiss scientists have created organoids from human brain cells that are being used as computer chips. This new field of computing where biological matter is being used in computers is being referred to as biocomputing. This new brain computer is being called a neuroplatform, and the Swiss team responsible is from an organization called FinalSpark. FinalSpark are considered pioneers in the field of biocomputing, and to quote their co-founder Fred Jordan, "As far as I know, we are the only ones in the world doing this." The computer itself is made up of a series of 4 processing units that host 4 spherical brain organoids each. According to FinalSpark, these organoids function similar to conventional computer chips in the sense that they can exchange information with each other by sending and receiving signals through their neurons which act like circuits. Unlike conventional computers, however, they have 1,000 times more memory and consume a fraction of the resources. Dopamine-induced processing. If you're wondering how you would get a human brain computer to do what you want, you're not alone. In fact, Fred Jordan was quoted stating the challenge is to find the appropriate way to get neurons to do what we want them to do. That being said, however, the Swiss team does seem to have found a couple of ways. Each of the 16 spherical brain organoids are connected to 8 electrodes which use electric current to stimulate the targeted neurons while also connecting the organoids to conventional computer networks. Additionally, and here's where it gets interesting, the targeted neurons are also exposed to dopamine, yes, dopamine, in order to simulate the way the brain's reward system works. While training human brain cells with electric shocks and dopamine in order to run AI workloads may sound like a perfect prequel to The Matrix and the Terminator movie series, FinalSpark isn't alone in its efforts. The Neuro platform is available for research institutes to rent over the internet for a fee of $500 a month, and while 34 research institutes have applied, about 9 have been granted access so far. These include the University of Michigan, as well as the Free University of Berlin. What's even more interesting is that each of these universities are working on a different aspect or angle of biocomputing, including but not limited to building organoid-specific computer languages and a standardized manufacturing system. If you're wondering what the catch is, well, here it is. Human brains die, and so do clumps of human brain cells. While the experiment's original organoids only survived for a few hours, at the time of writing this post, the researchers have managed to increase this lifetime to about 100 days. Additionally, the researchers have also fine-tuned the manufacturing process to a point where they have a stock of a few thousand organoids to work with. There is also a 24-hour live stream where anyone with the link can watch these organoids at work in real time. In conclusion, getting human brain cells to interact with conventional computers is a breakthrough in itself and could have limitless applications in a number of fields. The ethical aspect of having human brains working as computers, however, is something else altogether,